Section 5.4 half angle formulas. This section we're going to derive half angle formula from double angle formulas and use half angle formula to prove trigonometric identities. We called the double angle formula for the cosine or cosine of 2x. The first form is cosine square x minus sine square x. The second form 2 times cosine square x minus 1. The last form is 1 minus 2 times sine square x. So if we work on the third form, which is the cosine of 2x equals 1 minus 2 sine square x, and we'll solve for sine x. If we are solving for sine x, rearrange the term as cosine of the 2x minus 1 equals negative 2 sine square x, or we write it as 2 sine square x equals 1 minus cosine of the 2x, and then divide both sides by 2. We get sine square x equals the quantity 1 minus cosine 2x all divided by 2. Next, we're going to solve for sine x by taking the square root. Then sine x is plus minus the square root of 1 minus cosine of the 2x divided by 2. Now we derive the formula of the sine x using the double angle formula. As you see, the angle on the left side is a half of angle of the expression on the right hand side. In summary, the sine x is in the form of plus minus sine square root of 1 minus cosine 2x all divided by 2. The plus minus sign here is determined by the location of the x, which quadrant that is located. Now, if you replace the 2x with the value a, the double angle here becomes just a. So then the x gonna be a over 2, or a half of the a. Now we derive the half angle formula for the sine as sine a over 2 is plus or minus sine of the square root of 1 minus cosine a divided by 2. Half angle formula for the cosine would be cosine of a over 2 equals, again, plus or minus depends on the location or the quadrant that a over 2 is located. So the cosine a over 2 is plus minus sine of the square root of the 1 plus the cosine a over 2. And you see the difference of the sine and the cosine half angle. The sine, the numerator of the radicand is the difference here, and it's going to be the sum for the cosine. And it's proved the same way as what we derived the formula for the sine of the half angle. For half angle formula for the tangent is either 1 minus cosine a over sine a or sine a over 1 plus cosine a. Examples. The first one, if cosine A is 3 over 5, with A is between 270 degrees and 360 degrees. Or we can say that A in the fourth quadrant. For the cosine A, which is 3 over 5, by definition, it is x over r. That means the x equals 3, the r equals 5, and A is in the fourth quadrant. X positive, x is 3, r is 5, the y gonna be negative side. To find y using the Pythagorean theorem, so the square root of 5 squared minus 3 squared, that turns out to be 4. But in the fourth quadrant, y has to be negative inside. So y is negative 4. Now summarize, so y is negative 4. We are going to find sine of the A. Sine A, by definition, is y over r. The y value we just found as negative 4, r is 5. So the answer is negative 4 over 5. And the next part, sine of a half angle of the A. Sine of A over 2 is either plus or minus sine square root of 1 minus cosine A divided by 2. Which one is we're going to use plus or minus sine? So on the side notes, if A is between 270 degrees and 360 degrees, when you divide A by 2, you divide both sides of you divide all the way for the inequality expression. So divided by 2. So 270 degrees divided by 2 is 135 degrees, which is about on the left. And the right hand side, 360 degrees divided by 2 is 180 degrees. Therefore, the 135 degrees is in the quadrant number 2, and this is just the end of the quadrant 2. That tell us the A over 2 is in the second quadrant. If it is in the second quadrant, the sign is positive. So we're going to take the positive side here. Now, replace the value for the cosine A in the radical. So 1, I'm going to write as 1/2 multiplied by the quantity 1 minus the cosine A. Cosine A is 3 over 5. Simplify the numbers as 1 over 2 times 2 over 5, and turns out to be the square root of 1 over 5, or 1 over square root 5 for the value of the sine of the half angle A. For the cosine of half angle is similar way. Since A over 2 in the second quadrant, the cosine gonna be negative. And we're gonna use the formula negative square root of 1 plus the cosine A divided by 2. Avoid complex fraction. Again, we're gonna write divided by 2 as multiplied by 1/2. And then quantity 1 plus the cosine A is 3 over 5. Now we have square root of 1 over 2 times 8 over 5, or negative sine of the square root of 4 over 5, or negative 2 over square root 5 as a simplified form. You can do the rationalized denominator if you like, but this is good enough. So the tangent of A over 2, or the half angle of the tangent function. Since A over 2 in quadrant number 2, the tangent gonna be negative in sign. So we have negative, we have the sine and cosine. We can use the sine over cosine value as the general form of the tangent of the angle. So just for our convenience, we already have the sine and cosine half angle. We just use them. So the tangent of A over 2 is sine of A over 2 divided by the cosine of A over 2. Sine of A over 2 is 1 over square root 5, and divided by, so I'm going to use the way to avoid complex fraction. Sine of A over 2 divided by cosine of A over 2, which is negative 2 over square root 5. Rewrite the division into the multiplication of the reciprocal. So 1 over square root 5 multiplied by square root 5 divided by negative 2. Root 5 and root 5 cancel. We get the tangent A over 2 as negative 1/2, and it turns out to be a negative sign as we expected. So we are done.